Happy Monday! We're going to move on to another lesson today. Today we're going to be doing Unit 2, Lesson 8, which is divide multi-digit numbers. So we're going to be using those division process that we understand, and we're going to be doing some bigger numbers with it. So, using what we know. In 5th grade, you learned how to divide using modeled and partial quotients. So, let's take a look at this problem. For a fundraiser, the 6th graders have 288 bags of popcorn to sell. There are 3 6th grade classes. If each class sells an equal number of bags, how many bags of popcorn does each class sell? So we're going to use what we know. So A says, use a bar model to represent the problem. Fill in the whole and the number of groups. So, based off our question up above, how many do we have for our whole? How many bags of popcorn did they sell? It was 288. Very good. Then, what is the number of groups? It was 3. So, here's our problem setup. What division expression represents this problem? Well, we would take our whole, which is 288, and we would divide it by the number of groups, which is 3. So it would be 288 divided by 3. So C says, estimate the quotient. Remember, what is the quotient? It is the answer to a division problem, so we're going to estimate the answer. The quotient is around 90, okay? And our thinking for that is I can look at 288 and say, it's pretty close to 270. And we know that 270 divided by 3 would be 90. So D says use your estimate. At least how many bags of popcorn should each class sell? Well, based off that, we would say it would be 90. Hold on a second. There we go. So, using our estimate, there should be at least 90 bags sold per class. E says how many bags are left to sell altogether? It would be 18 bags, because between 270 and 288 would be 18. And so if we divided that by each class, that would be 3. 18 divided by 3 is 6. So how many more bags can each class sell? And then how do we know? Well, that would be 6 more bags, because we know that 6 times 3 is 18. So G says, explain how to find the total number of bags of popcorns each class can sell. Well, we would add our estimate, which is 90, plus our 6 to know that it would be 96 bags. So let's find out more. It says that you used partial quotients to solve the problem. So you can see we knew that 90 groups of 3 was 270. So then we subtracted to find out how many were left. So we did our 288 minus 270 to get our 18. We know that 3 will go into 18 6 times, so we would have 6 more. And then we would be able to add those two partial quotients, 90 plus 6, to get 96. So we would know that 288 divided by 3 equals 96. We can also use the division algorithm to find the quotient. That's basically the normal setup that we do. So this method is like partial quotients, except you need to pay attention to place value. So you know the quotient is around 90. So we're taking 288 is 28 tens and 8 ones. There are 9 groups of 3 and 28. So 9 times 3 equals 27. 28 minus 27 equals 1. So we're going through our normal division process. 3 goes into 28 9 times. 9 times 3 is 27. And then we subtract and get 1, and we bring down our 8. So we have 18. 3 goes into 18 6 times. 6 times 3 is 18, and we get our 0, so that we know that 288 divided by 3 is 96. So, to divide 343 by 9, would you use partial quotients or the division algorithm? Explain your reasoning. So, for this one, it's really up to you. Which do you think would be easier? Do you like dividing it into partial quotients where you see just parts and you add them together, or do you like following the normal division process? So on this one, you just need to fill in which one you prefer and then tell why. Alright, so in this one we're going to focus on the division algorithm. So we have a problem that says a family is heading out on a car trip of 672 miles to know what is known as the 6th most popular national park, the Blue Ridge Parkway. If they travel at an average of 56 miles per hour, how long will it take to get there? So we can estimate it. You can use compatible numbers to estimate the quotients. So we can say it's about 660 divided by 60, and we know that that would give us 11. We can actually model it and use our partial quotients to divide. So this is like what we did before. We know that 56 can go in there about 10 times, and then we would subtract to find the difference and know that it's 112, and then 56 goes into 112 2 times. Or we can do our traditional algorithm to divide. So we would go 56 into 67 one time, we multiply to get 56, subtract and get 11, then bring down the 2, 56 goes into 12 twice, 112, sorry, twice, and then we would get a remainder of 0. So, now compare the two methods dividing to solve the problem. Number 2 says, why does it make sense to use 660 and 60 to estimate the quotient? Really, it makes sense just because it's easy to divide 660 by 60. Sorry, back up once again. There we go. It's easy to divide 660 by 60. Number 3, how is writing the 1 in the division algorithm the same as writing the 10 in the partial quotient model? Well, it all has to do with the place value. So, the 1 is in the tens place, so it represents 10. Number 4, how is writing the 56 in the division algorithm the same as writing the 560 in the partial quotients model? Well, same thought as up above. The 56 represents 56 tens. Which is 560. Number 5, when solving this problem with the division algorithm, how is bringing down the 2 ones like the first subtraction step in the partial quotients method? Well, with the 1 up above, it tells us that our 56 tens represents 560. So if we bring down the 2, it would be the same as subtracting 560 from 672. So number 6, how long will it take the family to drive to the park? Well, you can look at our problems from the previous page. It would take 12 hours. And then how can you check your answer? We can multiply, because the opposite of division is multiplication. So we can multiply the answer, which is 12, by 56, to see if we get 672. Okay, number 7, how is using the division algorithm to divide the same as using partial quotients to divide? And then how is it different? Well, basically the thinking is the same. Hold on a moment. There we go. The thinking is the same. The only difference is you just don't write down all the numbers. Okay, so now I want you to try it. Use what you learned about dividing to solve these problems. Show your work on the paper. So, number 8, a grandmother has $490 that she wants to give to her 14 grandchildren. How much money will each grandchild receive if they each receive an equal amount? And then number 9, 18 students each collected the same number of cans for a project. If the students collected a total of 306 cans, how many cans did each student collect? So, work these out, take a moment, and then you can come back and check your answers. So please pause the video. Okay, now that you've worked it out, you can check your answers here. You can see if you take 490 and divide it by 14, you should get a total of $35 for each child. And for number 9, if you took 306 cans and divided it by 18 students, you would see that each student collected 17 cans. Okay, so now we're going to move on, dividing with 5-digit dividends. Basically, it's just going to be the same thing, it's just a little bit bigger of a number. So Sam's father bought a new car for $26,000, let's try that again, $26,304. He expects to pay for it in 24 equal monthly payments. How much will Sam's father have to pay each month? So once again, we can estimate it. So we can take our $26,000 and round it to $24,000 divided by the 24 months. It would be roughly $1,000 per month. We can model it using the traditional division algorithm. So 24 would go into 26 once. We'd multiply, subtract, bring down the 3, 24 goes into 3, 0, multiply, subtract, we'd get 23, bring down the next number, which is 0, 24 goes into 239 times, and we get 216, we subtract and get 14, bring down the last digit, which is 4, and 24 goes into 144 6 times, so we get a remainder of 0. Or we can use the partial quotients. So, let's connect it and answer some questions now. So, number 10 says, how much will Sam's father have to pay each month? So, looking back at the previous page, we would see that he could, hold on, back up again. It's been a while since I've done this. We can see that he would pay $1,096 a month. Is that answer reasonable? We can say yes, it is reasonable, because if we look up at the estimation that we did on the previous page first, we can see that it is roughly close to 1,000. So it is close to the estimate. Okay, number 11, look back at the division algorithm. What is 24 times 1,096? Well, if we multiply those together, we should get our original cost, which was $26,304. Number 12, suppose Sam's father decides to pay for the car in 48 equal monthly payments. How much would he have to pay each month? So we'd go back to what we did the first time, only instead of dividing it by 24, we would divide it by 48. So we're going to take 26,304 and divide it by 48. So 48 will not go into 26, so we have to take it into 263. How many times will 48 go into 263? It would go in 5 times. 5 times 48 would give us 240, and we subtract. 3 minus 0 is 3, 6 minus 4 is 2, 2 minus 2 is 0. So then we drop down our next number. How many times will 48 go into 230? It goes in 4 times. Remember, keep your numbers lined up above what they're going into so that you don't get confused. So 4 times 48 is 192. We subtract. We have to borrow. 3 becomes a 2. The 0 becomes a 10. 10 minus 2 is 8. Can't do this one, so we borrow again. 12 minus 9 is 3. 1 minus 1 is nothing. Drop down the next number. So now 48 will go into 384. 8 times 48 is 384. We subtract and get 0. So the answer would be he would be paying $548 per month. Number 13, why is it important to pay close attention to place value when dividing with the division algorithm? Well, because the position of the digits tell you the values of the numbers. If your numbers aren't lined up correctly, you will get different answers. For example, if you put the 5 over the 6, it wouldn't be a 500 anymore, it would be 5,000, and that would give you the wrong answer. So it's very important to make sure you pay close attention to where you're placing those numbers. So, now it's time for the try it. So, use what we just learned up above to show our work. So number 14 says, in a year, which is 12 months, a sports team practiced for a total of 1,305 hours. On average, how many hours did the team practice each month? Number 15, there are 1,891 students participating in the citywide holiday concert. The bus seats 62 students. How many buses will be needed to bring the students to the concert? So, use what we just did, set up your division problems, and divide them out. So go ahead and pause the video, work these out, and then you can resume it to check your answers. Okay, so now that you've worked them out, here would be your answers. For number 14, 1,305 divided by 12 would give you 108 and 9/12 hours. The way we get 9/12 is once you divided it out, you would get 108 and you'd have a remainder of 9. If you take that 9 and put it over top of your divisor, which is the 12, you would get your 9/12 hours. So number 15, you would take 1,891 and divide it by 62. When you do that, you get 30, remainder 31. Well, we're trying to take all the people to the concert, so you would need to make sure for your remainder that you add another bus so that they're able to go. So you would have 30 full buses, plus you would need to add one more to cover the ones that don't fit on the other buses. So you would need a total of 31 buses to hold everyone.